In this module, you will learn about the formation of covalent bond, the Lewis dot structures, and formal charge. Langmuir refined the Lewis postulates and introduced the term covalent bond. The bond formed by the mutual sharing of electrons between the combining atoms of the same or of different elements is called a covalent bond. During covalent bond formation, each atom tries to attain octet, that is, 8 electrons in its valence shell, or duplet 2 electrons in the first shell. The formation of covalent molecules can be understood from the Lewis dot structures. In the Lewis dot structures, the valence electrons of all the bonded atoms of a molecule are represented by dots. The following conditions are to be satisfied for the formation of a covalent bond in a molecule. Each of the bonded atom must contribute equal number of electrons to the shared pair. A bond is said to be formed when an electron pair is shared between the bonded atoms. All the bonded atoms must attain the nearest inert gas configuration as a result of sharing of electrons. Let us understand the formation of chlorine molecule by writing Lewis dot structure. The electronic configuration of a chlorine atom is neon 3s2 3p5. It has 7 electrons in its valence shell. Hence, it needs one more electron to attain the nearest inert gas configuration of argon. Therefore, each chlorine atom contributes 1 electron for sharing, and this electron pair is shared mutually by both the chlorine atoms. This shared electron pair joins 2 chlorine atoms together in the chlorine molecule. That is, if 1 electron pair or 2 electrons are shared between 2 bonded atoms, a single bond is said to be formed. Similarly, let us look at Lewis dot structures which depict the formation of covalent bonds in methane and carbon tetrachloride. Now, let us understand the formation of the oxygen molecule by writing the Lewis dot structure. The electronic configuration of oxygen atom is helium 2s2 2p4. It has 6 electrons in its valence shell. Hence, it needs 2 more electrons to attain octet. When 2 oxygen atoms approach each other, each of the oxygen atom contributes 2 electrons for sharing. Both the oxygen atoms mutually share these 2 electron pairs and attain the nearest octet configuration of neon. As the 4 electrons in 2 electron pairs are shared between 2 oxygen atoms, the 2 oxygen atoms are said to combine by a double bond in the oxygen molecule. Similarly, we can show the formation of carbon dioxide, ethylene, C2H4 molecules by Lewis dot structures as shown. Let us understand the formation of nitrogen molecule using Lewis dot structure. The electronic configuration of nitrogen atom is helium 2s2 2p3. It has 5 electrons in its valence shell and needs 3 more electrons to attain octet. When 2 nitrogen atoms approach each other, they mutually share 3 electron pairs and attain the nearest inert gas configuration of neon. As 6 electrons, that is, 3 electron pairs are shared between 2 nitrogen atoms, the 2 nitrogen atoms are said to join by a triple bond. Similarly, we can show the formation of acetylene, C2H2, and carbon monoxide molecule by Lewis dot structures as shown. Let us look at certain other important steps to be adopted while writing the Lewis dot structures for a molecule or an ion. In case a covalent molecule is formed between different atoms, then the atom with the least electronegativity is placed at the center, and other atoms will be placed at the terminal positions as shown here for a carbon dioxide molecule. Now, count the number of valence electrons available for bonding. In case of a molecule, count the total number of electrons present in the valence shell of all the bonded atoms. In case of ions, that is anions and cations, for each negative charge, add 1 electron to the total number of valence electrons, and for each positive charge, subtract 1 electron from the total number of valence electrons respectively. While writing a Lewis structure, it is always better to know the symbols for the respective bonded atoms or the combining atoms while you have to guess the skeletal structure of the molecule. This makes the distribution of the electrons between the bonded atoms easier. Among the valence electrons available for bonding, shared pair of electrons forms a single bond between two bonded atoms, and the remaining electron pairs present on the respective bonded atoms are either used for the formation of multiple bonds or remain as lone pairs. Finally, each atom should attain octet in its valence shell, except hydrogen, which attains the stable duplet configuration. Now let's see how to write the Lewis dot structure for carbonate ion by adopting the above-mentioned steps. First, let us calculate the total number of valence electrons in the carbonate ion shown here. The number of valence electrons in carbon is 4, whereas the number of valence electrons in oxygen is 6. As 3 oxygen atoms are present, the number of valence electrons in 3 oxygen atoms is equal to 18. As 2 negative charges are present on the carbonate ion, add 2 to the total number of valence electrons present in carbon and oxygen atoms. The total number of valence electrons here is 22. Hence, the total valence electrons in carbonate ion is 22 plus 2 equal to 24. In the carbonate ion, as carbon is less electronegative, it is placed at the center, whereas 3 oxygen atoms are placed around it at the terminal positions. The skeletal structure of carbonate ion is as shown. Now let us draw a single bond between the central carbon atom and each of the oxygen atoms. This, however, doesn't complete the octet on carbon, if the remaining 2 electrons on this oxygen remain as lone pair. Hence, a double bond between the carbon and the oxygen completes the octet. This results in the following Lewis dot structure. Now let's see how to write the Lewis dot structure for ammonium ion. First, let us calculate the total number of valence electrons. The number of valence electrons in nitrogen is 5, whereas the total number of valence electrons in 4 hydrogen atoms is 4. And as 1 positive charge is present on the ammonium ion, subtract 1 from the total number of valence electrons present in nitrogen and hydrogen respectively. That makes it 9. Hence, in the ammonium ion, the total number of valence electrons is 9 minus 1 equals 8. In the ammonium ion, nitrogen is placed at the center and the 4 hydrogen atoms are placed around it at the terminal positions. The skeletal structure of ammonium ion is as shown. When each hydrogen is bonded to nitrogen by a single bond, nitrogen attains octet and hydrogen attains duplet respectively, resulting in the shown Lewis structure. Let us now discuss about formal charge. In the case of monoatomic ions, the net charge belongs only to that particular atom. For example, chloride ion, oxide ion, sodium ion, magnesium ion, etc. In the case of polyatomic ions, the net charge is possessed by the ion as a whole and it does not belong to any particular atom. But we can assign a formal charge on each atom in the polyatomic ion. Formal charge is equal to the total number of valence electrons in the free atom minus total number of non-bonding electrons minus half of the total number of bonding electrons. While counting the electrons on the atom in a molecule, it is assumed that an atom owns 1 electron of each shared pair and 2 electrons of the lone pair. Let's calculate the formal charge on the oxygen atoms in the ozone molecule. In the ozone molecule, 3 oxygen atoms are present. Of these 3, 1 oxygen atom acts as a central atom. This is the Lewis structure of the ozone molecule. Let us number the 3 oxygen atoms as 1, 2, 3 respectively. Let us first calculate the formal charge on the first or central oxygen atom. The formal charge on it is equal to 6 minus 2 minus half multiplied by 6, which is equal to plus 1. The formal charge on the second or doubly bonded oxygen atom is 6 minus 4 minus half multiplied by 4, which is equal to 0. The formal charge on the third or single bonded carbon atom is 6 minus 6 minus half multiplied by 2, which is equal to minus 1. Remember that the formal charges do not show the real charge separation within the molecule. Formal charges are useful to predict the most stable structure among the possible Lewis dot structures of the compound. Now let's move on to limitations of Lewis theory. Though octet rule is simple, it is not applicable to all the molecules. It is mainly applicable to organic compounds and compounds formed by second period elements such as methane and water. Octet rule is not applicable for the molecules containing odd electrons. For example, there are only 7 electrons around nitrogen in nitric oxide. Octet rule is not applicable for the molecules in which the central atom has less than 8 electrons. That is, contracted octet. This is observed in the compounds or molecules in which the central atom in its elemental state possessed less than 4 electrons in its valence shell. For example, lithium in lithium chloride, boron in boron trifluoride and boron trichloride, beryllium in beryllium chloride, aluminium in aluminium chloride don't possess octet. The atoms of the elements that belong to the third period and beyond the third period possess 3d orbitals available for bonding. Hence, most of the compounds formed from them possess more than 8 electrons around their central atoms. This is called expanded octet. Hence, the octet rule is not applicable for the molecules such as phosphorus pentachloride and sulfur hexafluoride, etc. In phosphorus pentachloride, phosphorus, the central atom has 10 electrons in its valence shell. In sulfur hexafluoride, sulfur is the central atom and it has 12 electrons in its valence shell. We know that each atom gets stability due to octet in its valence shell. But some elements like krypton and xenon forms compounds in spite of having octet in the valence shell such as xenon difluoride, xenon oxydifluoride, krypton difluoride, etc. The octet rule couldn't explain this anomaly. Lewis theory does not explain about the shapes of the molecules. It also does not explain about the relative stability of the molecules as well as the energies of the molecule. You have now reached the end of this module. In this module, you learned that the bond formed by mutual sharing of electrons between the combining atoms of the same or different elements is called a covalent bond. The following conditions are to be satisfied for the formation of a covalent bond in a molecule. Each of the bonded atoms must contribute equal number of electrons to the shared pair. A bond is said to be formed when an electron pair is shared between the bonded atoms. All the bonded atoms must attain the nearest inert gas configuration as a result of sharing of electrons. In case a covalent molecule is formed between different atoms, then the atom with the least electronegativity is placed at the center, and the other atoms will be placed at the terminal positions for a carbon dioxide molecule. Formal charge is equal to the total number of valence electrons in the free atom minus total number of non-bonding electrons minus half of the total number of bonding electrons. Octet rule is not applicable to all the molecules. Octet rule is not applicable for the molecules containing odd electrons. It is also not applicable for the molecules in which the central atom has less than 8 electrons, that is, molecules that have contracted octets. Octet rule is not applicable for the molecules such as phosphorus pentachloride and sulfur hexafluoride, etc.